Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Gijs Meuleman, CEO of Sensorfy. Sensorfy builds the world's most accurate predictive solutions for manufacturers seeking to eliminate surprises from industrial maintenance. In this talk, we discuss how to transform a transactional business model into one that is service-based, data-enabled, and closely aligned with benefits for the end customer. We also explored the challenges in building predictive algorithms related to data availability, heterogeneous systems, and the inherent challenges in building a business case. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, you can email me directly at erik.walenza@iot1.com. Thank you. Gijs, thank you for joining me today.
Welcome. Yeah, great to be on the podcast.
Yeah. So this is, I think this is going to be an interesting one because the topic here is predictive maintenance, which has to be use case number one for industrial IoT. So it's something that most of our listeners will be familiar with, but I think we're going to find some interesting ways to kind of address this from a business perspective and look at it from different angles. So I'm looking forward to this because it's a topic that, at least for us at IoT One, comes up all the time. But before we get into that, I'd love to understand how you ended up setting up Sensorfy. I think it's always interesting when talking to a founder to understand a bit about the backstory. Where did the concept come from?
Yeah, great question. Thank you, Eric. Well, my name is Gijs Meuleman. I do have a background in electronic engineering from Eindhoven University and specifically into RF microelectronics. After finishing my studies in 2012, IoT was still relatively new. And actually, I thought I can do a better job here. I saw a lot of potential, and I just started as an entrepreneur. To be honest, I didn't think about it that much. Started as an engineering consultant, developing IoT solutions in general. At the time, I was also not so busy with thinking about scalability. Over time, we developed various IoT solutions in actually a wide range of industries. And from those solutions, we've built our technology stack, a set of modular hardware and software components. And that helps us now to make predictive maintenance solutions for our clients.
Yeah, so you were a researcher for a couple of years before you set this up in 2015 at Eindhoven University of Technology. Were the things you were working with there directly transferable to predictive maintenance, or was it more kind of fundamentally similar technologies but different solutions?
Well, it was similar in a sense. I actually did a PhD in RF microelectronics. I wasn't, and I know quite a lot about RF transceivers, which is an important part of IoT solutions. I didn't like being a researcher, so I actually quit after 2.5 years, and then I decided to start my own company.
Yeah, got it. So, aside from the fact that you thought you could do predictive maintenance better than what was on the market in 2015. Why start your own company? Why not join, Siemens or some large player here? What gave you the confidence to say, I as a relatively fresh grad can come out here and win in this market?
Yeah. Well, a really good question, Eric. If you can see, as you can see on my profile, I was an entrepreneur already since 2009. And I did some off-the-side jobs during my studies. So it was more like a natural choice for me.
Yeah, okay, got it. And I see also you've set up an investment company focused on real estate, which is very, very interesting and ambitious. Actually, it looks like a fun company, what you're doing there. But I can see that you really do have the entrepreneurial bug.
Yeah, true. That's something. It's a hobby that got a bit out of hand, but it's a
hobby that got out of
different
hand.
topic to discuss. Yeah,
Yeah, that's a good way to describe it. Yeah, great. Well, let's talk about this topic of predictive maintenance. So, again, I mean, it's a solution that most of our listeners will be fairly familiar with. Why is it the specific solution that you've decided to focus on? I think that's quite interesting because a lot of tech companies will say we focus on a particular vertical, we focus on a particular layer of the tech stack, but you've chosen a specific use case to focus your business on. And what about predictive maintenance struck you as a kind of a suitable scope for a business?
yeah, really good question. As I mentioned before, we started off as a generic IoT solution provider, and we did a lot of various IoT solutions. And 3 years ago, we decided to bring more focus and concentrate our efforts on a certain niche. And we look hard at our at the products we developed over the years, and quite a lot of them were about predictive maintenance. And I think if the business case in this field is pretty clear, and that makes us that helped us to make the decision to focus on this niche, mostly because we have quite some experience in that area.
Yeah, I think that's a smart decision. I think entrepreneurs often have hungry eyes, right? And so they wanted to find a problem as big as possible and envision their unicorn future. But it's much easier to be successful if you're focused. So I'm interested in looking at this from a couple of perspectives, just based on my personal experience with predictive maintenance. So maybe the first perspective is defining the business case, just from looking at it from a kind of a cost and efficiency perspective, and then we can look at it also from kind of the business opportunity or the opportunity to refine your business model around this. But just from a cost perspective, I mean, there's a couple of cases that I've seen recently or been involved with. And the first was a bit of a negative. So that was looking at automotive production lines. And you look at it and you say, okay, predictive maintenance makes a lot of sense here. And then you get deeper into it and you say, well, the reality is that at least here in China, there's excess capacity. So they're running at 85% anyways. They have a lot of scheduled downtime. And then you've got all these engineers that you're not going to fire because they're state-owned enterprises or because they need them anyways for other purposes. So you're not going to save headcount. And then the production lines all have slightly different equipment. So you're going to end up doing a bunch of different mini projects if you want to deploy this. And the business case just gets killed. And then you look at another case, and this is offshore wind, and you think, okay, flying somebody out there on a helicopter costs $100,000 round trip, and it's a killer business case. So you have two different situations, and one was difficult to justify, although I think that company is actually taking a second look at it. The second is very easy to justify. How do you, as really an expert in this, how do you evaluate the different parameters to decide, does a specific business case make a lot of sense, potential sense, or no sense?
Yeah, that's a really good question, Eric. So first, what you have in the predictive maintenance space, there are different parties. You have the asset owner that usually has a direct benefit of using predictive maintenance. Well, based on the industry, of course. But we mainly serve the industrial OEM market, and we do that by integrating our technology into their equipment or assets. That's our focus. And of course, we evaluate every opportunity to see if there is a clear business case. What we see is most of the drivers especially here in Europe, is the shortage of technicians. And IoT and predictive maintenance in particular will help to serve more customers with the same amount of technicians. And that's something that's very valuable over here.
Mm. Yeah, it makes sense. I think actually everywhere in the world right now, that seems to be an issue. Okay, so labor shortage. Nonetheless, I guess in the cases that I just gave, there's one where you would kind of assume that there might be a shortage, but in reality, there's not. And the other, there's an extreme challenge of getting technicians out there. Are there other variables you look at, or are there? I guess you have to evaluate your customers to an extent and determine, is this a customer that we're going to be able to serve long term, or is it going to be kind of they're going to figure out that this actually is not providing value? And so anything else on your checklist that you would be assessing to determine who's going to make a great long-term customer from as an OEM?
Yeah, so one of the other parameters we look at is what happens if the asset fails, and sometimes the impact is very very high, costly. That's of course an important parameter. The second one we look at is, okay, is this OEM also able to scale it? Usually a startup is it's much more difficult if it has the OEM as an established business over the world, and that helps to scale the solution and also make sure that they can gather enough data sets to really enable predictive maintenance.
Yeah, so there's another case that we're working on, which is company that does very large pieces of equipment, could cost $10 million. They are often going to be customized according to the requirements of the customer. So maybe some percentage will be standardized, but usually they're going to have different customized parameters. And what that means is that it's, I think, often going to be more difficult to train a model, kind of a predictive maintenance model, and then apply that to all of the machines in their fleet, because they're all going to have they're going to be collecting different data. They're going to be operating, behaving in different ways. Whereas if I'm just selling a pump, that pump model, I might have 10,000 units, and fundamentally the hardware is all the same. So it's going to be much easier to scale that. So how do you look at these situations where you'll have kind of customization in the OEM equipment?
Yeah, so we mainly work for we mainly work for OEMs, and they have very similar equipment. So one of our customers is a large supplier of automatic doors, and you see that although the door might be in its form might be different, the movements you detect and the algorithms you can develop based on that, they are very similar. So I think if you serve the asset owner, then there would be much more variability in the kind of assets, and it's much more difficult to provide a machine learning model for all the different types of equipment with quite some variations in them.
Okay, yeah, that's a good point. Okay, so you're looking at it when you're working with OEMs from more the component level of saying, okay, they're different, but they all use the same hinge, they all use the same engine, and you can standardize around that. Is there a short list of components that you find to be the most valuable, or maybe the easiest to do predictive maintenance on?
Yeah, so we focused on basically three markets. That's building assets, and that's real components, and that's industrial equipment. And within those markets, we see that we add value quite easily if it's linear motion. So any vibration data or linear motion, we have quite some experience with, and then it's easy to detect, or easier to detect the failure modes and mechanisms, and to help a customer quickly. So that's actually one of the parameters we're looking at when we select new clients, to make sure that we can be successful.
So linear motion, is that like a piston firing, or what? Give me a couple examples there.
So yeah, a good question is so within the building assets, automatic doors, but elevators, escalators, you can think of. Within the rail, we've done quite some vibration analysis of rail, or the rail itself, rail component, turnout systems. And with industrial equipment, it might be indeed hydraulic equipment, or other linear moving parts.
Okay, interesting. And why do you find that linear is easier to assess?
Well, it's not easier to assess, but I would say we have most of the experience with that.
Okay,
so it's easier to be successful. Also, there you have to find a niche. There are other players in the market that can derive predictive maintenance from voltages or currents, for example.
Oh, interesting. Okay, so it's more that you've built up this experience over X number of past projects. How transferable is this? Is it like what is the workload of doing, of supporting customer number 100 versus customer number 1, or maybe customer number 10?
Yeah. So over the years, we've built a IoT technology stack. It's a set of modular hardware and software components, and that enables us to quickly build tailor-made predictive maintenance solution for our clients. So that helps them to scale more quickly, although there will be some integration, always will be some integration. So we look at the scale of each OEM in particular.
Okay, so but can you give me like a number of hours? I'm just curious. Like if we look at customer 10, or if you were to try to do a new, you were saying, okay, we're going to extend beyond linear and we're going to start looking at voltage. What would be the effort required for you to figure out how to do voltage versus doing the next linear, the next project for a linear client? I'm curious because these economies of scale are so important in IoT. It's such a fragmented industry that finding economies of scale is actually challenging. And when you do find them, they're very valuable if you can really figure out how to scale them.
Yeah, indeed. A number of hours is difficult, but what I can say is like the throughput time to really industrialize a project can be anywhere from 3 months to up to 12 months, I would say.
Okay.
Yeah, and it depends on how difficult it will be to detect the failure mode. It's most of the time required is to really analyze the data and develop the model.
Yeah, and that seems to be a big issue. I mean, a lot of these industrial systems are designed, and of course, they're all designed not to fail, and a lot of them fail very seldom. So you have kind of maybe a lot of data, but very few failure data. What is that kind of data collection and training process? Do you basically work with the customer to put their equipment under a bunch of stress tests to force it to fail, or how do you make sure that you have the data that you need to work with?
Yeah, that's something we do together with our clients indeed, and sometimes they can simulate failures to make sure that we capture this data. Yeah.
Okay. So it's mostly a simulation, but I guess simulating in real world simulations.
In the real world, actually, yeah, indeed.
Yeah. Okay. And so if it's 3 to 12 months. What's the bulk of the time here? Is it manufacturing and training the data, or is it more collaborating with them to kind of figure out, the business model or how they're going to integrate this into their service offering? Or
it's basically a cycle of a product development. So you may have to make sure you have the requirements right, derive a first prototype, you develop the software, integrate that into this system, start collecting data, and then from that data derive a model, and that takes quite some time. One of our clients makes turnout systems. Yeah, developing such a product that detects failures within turnout systems is quite a challenge.
What is a turnout system?
It's used in what's a railway switch. So it's a similar name. So in railway, when you have two tracks, and in the intersection, it's called a turnout.
Okay, yeah, I've seen the term railway switch come up in newspaper articles about railway crashes, so I can appreciate the value there. Okay, great. So that's kind of on the deployment side, and then we've discussed some of the benefits from a more of a cost savings perspective. I think one of the things that you focus on as a business is helping your OEM customers to also develop new business models around this. So look at how they can use predictive maintenance to also modify their revenue model. What have you seen as kind of interesting cases or success cases in also developing new, maybe higher profit revenue streams around this?
Mm-hmm. Yeah, that's a really good question. If you look at OEMs, and traditionally they have more of a kind of a transactional business model. So they sell their parts, or they sell the asset to the asset owner, and then when something breaks down, they provide spare parts. And one of the interesting models that can be enabled by predictive maintenance is monitor your asset from a distance remotely, and give timely warnings to the asset owner when the product will fail. So one of the opportunities is to use predictive maintenance to enable them to sell a long-term service agreement. And then as time matures, they learn more about the failures of their assets. And that can help them to transition to a more outcome-based business model. So where they actually guarantee the performance of the asset at the asset owner, and that's in direct benefit with them because they want to use the asset as long as possible with the lowest amount of total cost of ownership. That's an opportunity for OEMs to transition to service-based business models, which we see happening more and more now. And predictive maintenance can really enable that.
And I guess you could do this in different ways. So the simplest way would be just to add a SaaS solution on top. So I sell you the hardware, and then I sell you for whatever, $100 a month per asset. I sell you this predictive maintenance solution. The more transformative way to do that would be to say, I'm going to lease you the asset, or I own the asset, but you use the asset, and I then use this software to make sure that I can optimize kind of the uptime and so forth. Where do you see the market today in terms of adopting different models here?
Yeah, so that's correct. You start off usually with a monthly fee, indeed, where you give them some insights on what the health of the asset is, and then as your confidence as an OEM matures, you can shift maybe your focus more on an outcome based, and indeed what you said, leasing the equipment and making sure that the equipment is always running, has no downtime. That's a fully outcome-based business model. What I currently see is that there's still a mix. So companies that are already quite far in this cycle still use a basic fee, a more basic monthly fee, and then maybe a bonus when the uptime is higher than expected, or a malus when the uptime is lower than expected.
Oh, that's interesting. I haven't heard about kind of this bonus structure, but that makes sense. Is that common, or?
It's not common yet, but I see several companies, industrial companies, moving towards this. And if you can figure it out and it really, really works, then you can, I think, be one of the winners in your particular industry.
Yeah, no, it's an interesting concept. I mean, this is one of the most kind of interesting areas for me around the IoT space, is that there's so much room for invention of the relationship, right? When you have data, you can really reinvent the relationship with your customers. Maybe another thing that sometimes sits as a kind of a hidden benefit here is the use of the data that you're processing and the insights for other functions, right? So if you think about kind of the value creation as a stack, right? You have, one element of the stack is reducing labor expense for your maintenance team. Another element is reducing downtime. You have other things like maybe providing data back to your R&D team, so that your R&D team can understand where failures have been more accurately, and they can design the next generation of the product to be superior. Where do you see much effort from these companies to really kind of dissect the data and look at how it can be used by other functions outside of the core job of predictive maintenance?
I haven't noticed it that much yet, but I do see the value there. You can actually see how the equipment is used in the field, and then based on that, you can indeed your next generation of your equipment. Yeah, you can derive specifications from that. I absolutely agree, but that are long-term cycles, which I haven't seen an example yet.
Yeah, exactly. That's the problem. It's always easier to envision something in this market than it is to actually realize it in the field, right?
Yeah.
Okay, cool. Well, tell me a bit more about your company. So, we already know now what you do. You mentioned the industries. Who are you typically working with? Is it more medium-sized businesses? Is it large businesses? Is it, I guess, primarily European? Or who are the typical customers for you?
Yeah, that's a good question. So what I mentioned is our customer is our OEMs, usually well-established OEMs with a existing market, and they really see the opportunity in servitization of their equipment. Mostly, we serve European customers, but they ship their equipment worldwide.
Yeah. In terms of, I don't know if you have that much visibility into this, but in terms of the end markets where, especially these servitization models are adopted, I mean, I feel like Europe might be a bit at the cutting edge. I think China, where I'm sitting, it's a bit challenging to get people to adopt. I mean, even cloud often just won't work in China right now for industrial. So there's some issues that need to be resolved more at the human level before some of these systems are adopted. But do you have much visibility in terms of the end markets and which markets are most ready or kind of willing to start looking at cloud-based software or new business models?
I do have some visibility there. Indeed, what you mentioned, well, sending data to the cloud is still a challenge, especially in the oil and gas industry. They're quite they don't want to share their data usually outside the plant. But over the years, I've seen quite an adoption of the cloud, and more companies realize the benefits and are willing to send their data to a cloud system and see the benefits of that.
Yeah. There's a clear trend line, right? It's just a question of industry by industry, country by country, right? How this moves.
Yeah, true.
Well, how about in terms of who you're working with? So are these, if a company is saying we're going to start looking into offering this new, digital service, whereas in the past we were selling just hardware, is this treated more as a just kind of a pure technical integration, where it might be like the product manager who's leading the engagement and is your touch point, or is it more of a strategic topic where the CTO is getting involved? Or the business unit head? Who are the typical stakeholders who are making the decisions around adopting these solutions?
We see them from two layers. Actually, of course, management has to be involved. There has to be a vision on digitization and how the company wants to make use of that. And then our typical touch point is with R&D. So they already defined a strategy and see that predictive maintenance is one of the topics they want to address in their next product, and that's where we come in and we help them shape the requirements of their of this strategy and help them integrate the technology, really make it remove the complexity for them, and afterwards we help them with the analysis of the data and also designing the model. Which can be done only after the collection of various data points, of course.
Mm. Yeah, and each of these is kind of a discrete project itself. So, what does your offering look like? It sounds like you have some standardized software you've built up, but you're also probably using more an array of off-the-shelf hardware, and you have your services. What does that look like as a package?
Yeah, so we've our technology. We built our technology stack, and that's that are different components. We have standardized hardware for our sensors. We can customize that. We have an integrated software layer in the cloud, and we have an insight hub, which where we can analyze the data and really integrate the model, the predictive maintenance models, and show them the insights. But usually it's an integration with their system as well.
Got you. And when it comes to the cloud, are you built on any particular cloud, or are you agnostic?
We've worked with many different cloud vendors, but we've mostly experienced with AWS.
Okay.
And the technology stack they're using there.
Okay, got it. And then when you look at topics like cybersecurity, is this something that you're leaning on AWS, for example, to secure the data, or are there any areas there where you have to kind of get involved in these topics?
Yeah, so most cloud providers have solutions for that, using certificates and making sure that the data you send from your device or your gateway to the cloud is actually secured. We're building on top of those solutions, and that could be in AWS, but you have them in Azure or Google Cloud as well.
Okay, so that's not such a big issue. Is it always the case that predictive maintenance is kind of a self-contained system in that you deploy the sensors and so forth, or are there cases where you might need external data from upstream, downstream in a process? Is that ever the case, or can you always basically accomplish the job with the sensors that you're going to be deploying directly on the OEM equipment?
Well, it's a combination. So since we integrate the technology, we also integrate with the system of the electronic systems that might be already available inside the equipment. So we extract data from there, and on top of that, we usually use several different sensors based on the specific equipment we're looking at.
Okay. So you might be looking at, I don't know, voltage or just energy flows, things like this that could also be relevant.
Yeah, indeed.
Yeah. Okay. Got it. Yeah, great. Is there one or two cases that you could walk through just to give us kind of a perspective in terms of what it looks end to end? I'd also be really interested in hearing some results that some of your customers have had.
Yeah, that's a good question. One thing I can dive into is the product we built for a large OEM of automatic doors. There we've built a sensor that's being put on a door that measures different parameters based on vibration, temperature, and based on the vibration events, you can and some edge analytics, we can detect several failure modes, and all of these failure modes are sent to the cloud. Technicians can then directly interact with those with this data, and then based on that, they can also do an automatic scheduling of a maintenance technician that will go there before the actual breakdown, and that helps to serve more customers, of course, with the same amount of people. But also to reduce any unplanned downtime.
So, what is in a case like this? What is considered a good success rate? I guess you could look at it in two perspectives. So, what is the time period before a breakdown that you can predict? Are you predicting 6 months in advance or 2 weeks in advance? And then, what's the accuracy level of the predictions? What would typically be kind of good good ranges here?
Yeah, that's a good question, but I don't know actually.
Oh, okay. Why is this? I mean, for this specific case, you don't know.
Specific case, yeah.
If we just look more generally, then not at this case, but in general, what would you consider to be kind of? I guess it depends, on the situation, but what would be reasonable ranges? Because I think the challenge here is you can always accomplish something, right? But the question is it is it accurate enough that it's going to make a significant impact?
Yeah, that's true. And you don't want too many false positives as well. So it's being accurate. It's possible to have a 3 to 6 month window for some type of equipment. But it really depends on which equipment you're looking at.
Okay. So somewhere in but we're looking at months in advance notice.
Yeah, that's possible.
And then accuracy rates, is there any kind of standard range that you would say is good, or is it just all over the place depending on the situation?
Yeah, that's something I cannot generalize.
Yeah. I guess in some cases you're looking at 99.xxx accuracy, and in other cases somewhat less. Yeah. Yeah, great. Then I guess the last question from me, I think we've covered this from a few different perspectives. Is there anything that we've missed here around predictive maintenance that would be important for folks to understand?
Well, predictive maintenance is what I would say is it doesn't start with the technology. We should really start with the business model in mind. It's a great technology. There are very potential, a lot of benefits can be reached from them. But you should start at looking at the business model first. And then, the technology and all the technology stack will come later.
Yeah, makes sense. And I think that's probably the opposite from how a lot of companies look at it. They want to do a pilot project, and then they want to look at very direct cost benefits, which is kind of a very simple way to look at it, but often not the comprehensive way. Yeah. Great. Well, what is the best way for folks who are interested in learning more about predictive maintenance to reach out to you, or to get in touch with the team?
Yeah, the best way is to go to our website. It's www.sensorfy.ai/contact, and there you can reach out. And if you have any, or if you are an OEM and you want to increase your business through servitization and predictive maintenance, or if you're involved in predictive maintenance inside an OEM company, we can help you to eliminate the complexity and quickly set you up for success.
Awesome. Gijs, thanks for coming on the show today.
Yeah, thank you for having me.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.